Welcome to Study Loop.
For A, the probability of finding the atom between 0 and a over 2 is the probability of finding it less than a over 2. So this is equal to the integral from 0 to a over 2 of the wave function 1s squared, which I wrote the wave function above. R here is the distance away from the center, a is the Bohr's radius, times 4 pi r squared. We're dealing with a sphere integrated over dr. So let's go ahead and replace that with a psi squared, and we're going to pull everything that's not related to r out front. So we have 4 over a cubed. The square root goes away since we squared it. And we integral from 0 to a over 2 e to the minus 2r over a r squared dr. So I would recommend doing u substitution. You could also integrate by parts, or you could just use an integration table. To not spend too much time doing this, I chose to go ahead and use an integration table. So what I have here is the probability P is equal to 4 over a cubed and this comes out to equal ar squared over 2. Again, so a series expansion into this and then using integration by parts would be the correct way. This could be lengthy. So this is how I use the integration table. So we have ar squared over 2. R look there. There we go. Minus a squared r over 2 minus a cubed over 3. And of course, this is all multiplied by e to the minus 2r over a. Since it's exponential, that isn't going to go away. And then from 0 over 2 is our range of integration. E and 0 and a over 2 into r, and then subtracting that from plugging 0 into r, and considering the fact that e to the 0 is equal to 1, what we end up with is 1 minus 5 over e to the minus. Okay, so carrying out that operation, we find this is equal to 0.0803. We can box that in as our solution. Okay, so for B, now we are asked to use the results of A and of example 41.4 to calculate the probability that the electron will be found at a distance between a over 2 and a. So from 41.3, the probability that the electron is found less than a, so we can call this, let's call this P prime, is equal to 0.323. So hence the probability that it lies between a over 2 and a is just going to be P prime minus P. Which is equal to 0.243. We can combine another solution to the question.